So class P, we're going to talk about some higher order equations. Higher order just means higher powers. So third degree, fourth degree, etc. If I should turn this, yeah, that's better. Okay. Not that I need to be on camera all the time. And then we've already kind of talked about it, but we will look more at factoring by grouping. And then we will also look at a quadratic form U-substitution. And I should be a little bit careful here. I will just warn you, when any of you take Calc 2, which at UC Davis is the B class, so 16B, 17B, or 21B, you will learn a method of integration called U-substitution. And it's a similar idea in that you're going to be replacing things with the variable U or whatever letter you pick. But it's a little bit different in how, like this U-substitution we're going to be doing, while we're still going to use that same idea, we're not doing exactly the same thing. So this U-substitution and the U-substitution you do in Calc 2 start the same in that you pick something for U, but they go in wildly different directions. So just don't confuse them in the future. Don't think what you do later on is the same exact thing as this. But let's look at some equations. Let's solve something like x to the fifth equal to 9x cubed. And what I should really say at the beginning is whenever you're solving an equation that has a degree that's greater than 1, or really a degree that's different than 1, right? Because you could have negative powers and so on. You should always be setting the whole thing equal to 0. The only time you ever really want to just isolate x is when you have a linear equation. So if you had something like, 5x plus 2 equal to 3x minus 7, this would be the time to just solve for x. Subtract 3x and subtract 2 to get 2x equal to -9, to get x equal to -9/2. This is the only kind of instance where it's really a good idea to isolate x. Any other time, you want to take your equation and bring everything to one side. And if your name is James Parmenter, you're always going to pick the side where x is positive, where the highest power of x has a positive coefficient. It is also perfectly okay to do it this way. They'll both lead you to the same answer. I just happen to like doing it this way. And there is a reason for it, which I'll get to eventually. So if I was solving it this way, then I'm going to factor out the highest, or I should say the greatest common factor, which in this case is x to the third power. So we're going to have an x to the third times an x squared minus 9 equal to 0. And then I'm going to factor this further. So I'm going to have x cubed times x squared minus 9 is a difference of squares. It factors as x minus 3 times x plus 3. And then we get x cubed equal to 0, which leads to just x equal to 0 by taking the cube root of both sides. But really you can see, right, the only number cubed that's equal to 0 is 0. And then this is going to lead us to x equal to 3. This is going to lead us to x equal to -3. And I should really stop using this pen because it's really just like totally out of ink. Okay. Or we could have done it this way. Here, I would still probably factor out an x cubed. So x cubed times 9 minus x squared. And if you factor 9 minus x squared instead of x squared minus 9, it is going to factor slightly differently. You're going to have 0 equal to x cubed times 3 minus x times 3 plus x. Slightly different. Still get the same results, but a slightly different equation. So this is going to give us x equal to 0. This is going to give us x equal to 3. This is going to give us x equal to -3. Still the same answers. And that's how I typically do it. I will point out, because it's fine, yeah. Another way some people would go from this step right here is just to set each part equal to 0. So at that part, you could say, oh, I'm going to say x cubed equals 0 and x squared minus 9 equals 0. This one here leads us to x equal to 0. yes, we could write the cube root of 0, but that really just seems like a waste of space and time. And here I would again factor x minus 3 times x plus 3 equal to 0. Yes, there are other ways of solving this. You could totally do x squared equal to 9 and then x equal to plus or minus the square root of 9. But that's not what I recommend. I really, really strongly, just can't strongly enough emphasize, if you can factor, that's usually the better way to go. It's safer. That's kind of the best description. Factoring is the safest way to deal with an equation of higher order and ensure that you don't miss any possible solutions. Because if you don't factor, it's easy to kind of miss something. Like, oh yeah, I didn't do the wrong thing. The wrong thing people like to do with this, which is wrong, is to divide both sides by x cubed. So if we divide by x cubed, we end up getting x squared on the left and 9 on the right. You still get some of the answers, -3 and 3, but you miss out on 0 as an answer. So just be careful. It's usually not a good idea to divide by your variable because you often lose possible solutions. Okay. So let's look at some other equations. Like we want to solve 2x cubed plus 2x squared equal to 6x. And just like before, we're going to bring everything to one side. And I'm going to bring everything to the left side, or the side that has the highest power of x with a positive coefficient. So I'm going to write this as 2x cubed plus 2x squared minus 6x equal to 0. And then we're going to factor out. And so factoring, when someone says factor, they usually mean two things at once. They mean first, factor out any possible greatest common factor. So there are 1, 2, 3 pieces here, and each of those pieces has both a 2 as a factor and an x as a factor. That's the greatest common factor to all the pieces. And I'm going to factor that out before I do anything else. So I'm left with an x squared. I'm left with a x, and I'm left with a minus 3. And now, normally what I would do is I would try to factor that. But I think you guys might know that doesn't factor. Right? There's no numbers that multiply to -3 and add up to 1. I know I use an x there. That's a times to -3 and an add to 1. Doesn't work. Can't do it. There's no numbers. So this is where I am going to kind of do the same thing I did before. I'm going to set each of the factors equal to 0. That's always what we're doing when we factor something equal to 0. We're setting each individual factor equal to 0. So I'm going to set 2x equal to 0. And I'm also going to set x squared plus x minus 3 equal to 0. This one clearly is going to get me x equal to 0. This one, since we couldn't factor this quadratic equation, we have to use the quadratic formula. There's nothing left. So we're going to get x equal to -1, which is our b, plus, or I should say that's our negative b, plus or minus the square root of 1 squared minus 4 times 1 times -3. Notice how I'm kind of omitting the things I don't really need to write. And then we're going to simplify this. We're going to get x equal to -1 plus or minus the square root of 1 plus 12 all over 2. And there really isn't any simplifying of that. If you really, really wanted to, you could write it as 3 separate answers. X equals 0, -1 plus root 13 over 2, and -1 minus root 13 over 2. But honestly, there's no need to write it like this. If you write it like this and like this, that is more than fine. It's good. It's more than fine. It's good. But I feel like I should give you one more example. Let's do that one. Cool. So let's look at, I think I have enough room here. Try not to waste so much paper. Let's try and solve, and let's use a different color just to make sure. Oh, wow, I just pulled my pen apart. That's good. That's not what I wanted to do. I was trying to like do this, but I would do this instead. Sometimes you gotta remember which pen works. Let's try this one. 6x to the 4th plus 3x cubed equal to 9x squared. Yeah. So again, I'm going to bring everything to the side where the highest power has a positive coefficient. I'm going to get 6x to the fourth plus 3x cubed minus 9x squared equal to 0. And then I'm going to factor out the greatest common factor, which is looking like a 3, because each of those has a factor of 3. And the highest power of x they all share is x squared. So then I'm left with a 2x squared here, a 1x here, and a minus 3 here. And so here's the thing. This does factor. I can try to see how to factor it. So let's see. The problem is writing it all at once is kind of, I don't know, it's kind of annoying, right? Like we could definitely say, okay, I want 2 times minus 3, that's negative 6. I want to multiply the negative 6, and I want to add up to 1. So I want a positive 3 and a negative 2. So I totally could write this as 2x squared minus 2x plus 3x minus 3. But it's a lot of writing. And I could say it's 3x squared times, from here I factor out the 2x, and I have an x minus 1. From here I factor out the 3, I'm left with an x minus 1. And then from each of these I factor out the x minus 1, so I'm left with an x minus 1 times a 2x plus 3. That seems a little, I don't know, just, it doesn't seem efficient to do it this way. But doing it this way, we end up getting x equal to 0, x equal to 1, and 2x plus 3 equal to 0 gives us x equal to negative 3/2. That's a perfectly fine way to do it if you're really bent on factoring it. But I don't feel like it's the best. I feel like from this stage right here, and again, right, if I'm just trying to solve the equation, I would probably say, well, I know I'm going to get for sure x equal to 0. And then I'm going to set the other part equal to 0. 2x squared plus x minus 3 equal to 0. And then you can either factor that or use the quadratic formula. And either way would be perfectly fine. The factoring we already did, right? You could totally just go through those steps again to get x minus 1 times 2x plus 3. Or you could do the quadratic. You'd say from this, x is going to equal negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 3 all over 2. And that's 1 plus 24. So you end up with not enough space, negative 1 plus or minus the square root of 25 all over 2. Negative 1 plus 5 is 4 over 2, which is 2. That seems like I'm making some dumb high. I missed the 2a on the bottom. So that's a good question. Sorry, let me fix this first before I answer that question. There should have been a 2 times 2 on the bottom. 2 times 2. So negative 1 plus 5 is 4 over 4 is 1. And negative 1 minus 5 is negative 6 over 4, which reduces to negative 3/2. So either way, we do get the same answers. And someone asked, do I find it easier to use the quadratic formula or factoring? Well, here's the thing. For this problem on the left, I couldn't factor, right? So the thing is, the factoring is not always an option. My usual preferred way of going is to factor if I can see it relatively easily, but then if I can't, to use the quadratic formula. But clearly we have to be careful. It's really easy, obviously, today and yesterday, both times I missed some of the bottom part here. So we need to be extra careful. At least I need to be extra careful when I'm using the quadratic formula. But it really, I should say, is personal preference. If you are better at factoring, do the factoring. But again, sometimes you're going to have to use the quadratic formula. So let's look at, oh, I skipped one here. That's fine. So let's try and solve this one. So 7 equal to 7x squared plus 28x. So here's the thing. I really don't want to bring everything to the left. Right? I would prefer to bring everything to the side where x squared has a positive coefficient. So I would do it like this. 0 equal to 7x squared plus 28x minus 7. But I will mention it is also perfectly fine to do this. Negative 7x squared minus 28x plus 7 equal to 0. Well, I guess I should follow my own advice and factor out a greatest common factor. So I can definitely see that I can factor out a 7. So 0 is equal to 7 times x squared plus 4x minus 1. Or if I was doing this, I could totally factor out a negative 7, and I would factor out a negative 7. So this doesn't factor, right? I should say this doesn't factor any further because technically it factored. We factored out a 7, but this doesn't factor in the usual trinomial way where you have x plus or minus something times x plus or minus something. Right? You can't multiply the negative 1 and add up to positive 4. Or similarly, you can't multiply the negative 7 and add up to, sorry, I'm getting that backwards. Apologies. You can't add up to 4 and multiply the negative 1. Or you can't add up to 28 and multiply the negative 49. Doesn't work. There's no way to do it. Now, here's the thing. We are going to have to use the quadratic formula here. Do I want to use it on this or do I want to use it on this? Well, either way is going to get me the same result because solving this equation is the same as solving this if I divide both sides by 7. Right? 0 divided by 7 is equal to 7 times x squared plus 4x minus 1 divided by 7. So we get 0 equal to x squared plus 4x minus 1. So if you're solving an equation, it is perfectly fine to divide both sides by a constant. Not by a variable, but definitely by a constant. And solving this with the quadratic formula is going to be much nicer than trying to solve this with the quadratic formula. For this one, I'm going to get x equal to negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 1 all over 2 times 1. And that's going to give me negative 4 plus or minus the square root of 16 plus 4 is 20. 20 is 4 times 5. The square root of 4 is 2. This is negative 4 plus or minus 2 root 5 all over 2. And then each of those parts divides by 2. People often do this kind of thing when they're dividing each thing by the denominator. And you get x equal to negative 2 plus or minus the square root of 5. And those are our two answers. I will mention, right, if you did it this way, technically you would get the same answers, but it's going to look like a lot more work. Right? Doing it this way, you would start off with x equal to negative 28 plus or minus the square root of 28 squared. Nobody wants to do that. Minus 4 times 7 times negative 7 all over 2 times 7. Right? That's terrible. We don't want to do that. So if you are going to use the quadratic formula because you have to, it's always a good idea to divide both sides by whatever constant multiples you can. No, that's an excellent question. Is 0 also a solution because of the greatest common factor of 7? It is not. So when we look at this here, right? So when I get where you're going with this. So let's talk about that. So if I have 0 equal to 7x squared plus 4x minus 1, we typically solve things, products, equal to 0 by setting each factor equal to 0. So technically my solutions are the following. My solutions are x squared plus 4x minus 1 equal to 0, or 7 equal to 0. But 7 doesn't equal 0, right? They're very, very different numbers. So this isn't a solution because it's not true. But I get what you're saying, right? Normally, if you had like an x out there, you'd be like, oh, x equal to 0, but that's not what we have. So yeah, so if you have a constant multiple, it doesn't contribute to any solutions. Another thing to think about is that when you have a polynomial equation, the number of solutions you get is always less than or equal to the highest power of x. So here, the most solutions we could get is 2, because the highest power of x is 2. And that's what we got. We got 2 different solutions, -2 plus root 5 and -2 minus root 5. I will also point out, we don't always get that many solutions. Like in our very first example, our equation had an order or degree of 5, but we only got 3 different solutions. So that highest power of x is just a cap on how many solutions you can get, but it is not always going to be the number of solutions you get. And what's really happening here is 0 is a thrice repeated solution. 0 is actually a solution 3 times, because you have x cubed equals 0. And 3 and -3 are each solutions once. And then somebody else has something too. So that's a great question for office hours. I'll address that then. Oh, actually, no, okay, I see what you mean. Okay. So the reason this 2 cancels there and there is because we're dividing the whole thing by 2. So another way to read this is -4 divided by 2 plus or minus 2 root 5 divided by 2. Or another way to kind of see it is you can factor out a 2 from the numerator. I'm kind of out of space, but I guess I'm going to write it down here. So if I take this numerator and factor out a 2, I'm left with a -2 plus or minus root 5 all over 2. And then that 2 can cancel with that 2 right there. So that's why that's working that way. All right. So higher order things, most of the time, well, I shouldn't say most of the time, some of the time, we're just going to try factoring as much as possible. And usually the thing that's going to happen is you're going to factor out some greatest common factor, and the leftover part is going to be a quadratic. And then you can apply your usual quadratic solving skills, either using the quadratic formula or using more factoring to solve it. And those are kind of our options. And then we have factoring by grouping, which you all are certainly aware of in one form, like solving quadratic equations. For example, if I wanted to solve 8x squared plus 14x plus 3 equal to 0, I'm going to solve that by, well, if it can factor, I'm going to try factoring it. And let's see, I have a times c is 3 times 8 is 24, and b is 14. And I want to add up to 14 and multiply to 24. God, am I saying it the right way? Yeah, I feel like I'm always like getting it backwards, to be perfectly honest. I think that's going to be 2 and 12. Right? 2 plus 12 is 14. 2 times 12 is 24. Seems to work. So I'm going to rewrite this as 8x squared plus 12x plus 2x plus 3 equal to 0. And then I'm going to factor by grouping. Again, we're always just doing it pair by pair by pair. So here I can factor out a 4x. I'm left with a 2x plus 3. And here I already have what I want, so I'm factoring out a 1. So it's 1 times 2x plus 3. And then from each of those, I can factor out a 2x plus 3. And I've got a 4x plus 1. So setting 2x plus 3 equal to 0 leads me to x equal to -3/2. And setting 4x plus 1 equal to 0 leads me to x equal to -1/4. But there are other types of problems where factoring by grouping kind of, oh, question 9, yeah.
Oh, I just had a question. I remember Sarah, she kind of gave us like a bunch of methods, and I'm like comfortable. I don't know if you know with the box method, and is it okay if I continue to use that?
Totally, yes. You can factor literally any way you want. I'm just showing you what I'm used to seeing and used to doing. But and like I would probably use the box method if I actually knew how it worked. but like, I just never learned it. So I'm like, you put things in boxes and something works. I can't do it. But if you can do it, I can certainly understand what you've done and be like, oh yeah, that looks great. And some of you did that on homework already, perfectly fine. Yeah. So again, I'm going to reiterate this many times. Do what works for you as long as it's right. As long as you're using a right method to get to the right answer. I don't typically care what method you're using, and no one should. There are some exceptions to that. Occasionally when someone says do this thing a certain way, but most of the time, that is not the case. We can also factor things by grouping that are higher order, like something like this: 4x cubed plus 12x squared minus 9x equals 27. So in this case, well, I'm going to bring everything to one side. And again, I'm going to write it in the standard way where the powers of x decrease as we go from left to right. But now this is something we don't really have experience factoring. There are methods to factor higher order things, and they involve something called the rational zeros theorem, which we're not going to talk about here. But that's not what this problem is about. This problem is about observing that, one, we have an even number of terms, which means we might being the very, very key word here, we might be able to factor by grouping. So we're going to try it. So from the first two terms, I can see that there is a 4x squared as a greatest common factor. Left of an x plus 3. And now is here the thing that has to happen is when we factor out the greatest common factor from here, the leftovers have to be the same. If they're different, we have to stop and do something else. So from here, I'm going to factor out a -9 and be left with an x plus 3. And the important observation here is, oh yeah, this and this are exactly the same. So we can continue. We can say, oh great, this is going to be x plus 3 times 4x squared minus 9 equal to 0. Now, interestingly, we can continue to factor. This quadratic certainly does factor. It factors as 2x minus 3 times 2x plus 3. But you don't have to do that. You can just say, I want to say x plus 3 equals 0. Great. I get x equal to -3. And then I can say 4x squared minus 9 equal to 0. And then I can factor that. 2x minus 3 times 2x plus 3. Now that one is easy to factor because I can see it's a difference of squares, right? I have 2x quantity squared minus 3 quantity squared, and it factors as 2x minus 3 times 2x plus 3. This multiplies back to 4x squared, that multiplies to 9 minus 9, and the middle terms cancel. I get a plus 6x and a minus 6x, which cancel each other out. So this is going to lead to x equal to positive 3 halves, and this is going to lead to x equal to negative 3 halves. And those are my 3 solutions. The most I can get. You can't just say x equals 9/4 because it's not. You could say, so what you could say, although it's not the path I generally like to take, you could go a different route. And again, this is the less safe route, danger. You could say, I'm going to do it this way, James. 4x squared equals 9. X squared equals 9/4. And then you can square root both sides and say that x is plus or minus the square root of 9/4, which is plus or minus 3/2. That would also be a valid solution. That's also a good question. Why would it be x plus 3 times 4x squared minus 9 and not x plus 3 minus 4x squared minus 9? Okay, great. So the thing is, right, what we're doing from this step to this step is we are factoring out an x plus 3 from the 4x squared minus 9. So if you look at this, from this step right here, if you want to distribute it back in, so if I have x plus 3 times 4x squared minus 9, what I'm doing is I'm distributing this whole thing to each of these terms. And I'm getting x plus 3 times 4x squared, and then x plus 3 times minus 9. And so this is the same as this, written slightly differently. But the idea there is, right, it's not, it's, so when we go from here to there, right, we are not saying it's this factor minus whatever's left. It is really this times that. So that when we multiply it back out, it is the same thing we started with. Okay. Let's look at some more examples here. Yeah. Oh, that's not what I wanted. Sorry, brain. Let's look at another example or two. Let's say we had something like, sure, 9x cubed plus 15x equal to 6x to the fourth plus 10x squared. And we want to factor this. So, well, we want to solve this. I should really say. We want to solve it by factoring. You can go to any side you want. I'm going to typically pick, so I'm going to go the way I usually wouldn't go. So I'm going to bring everything to the left here. I'm going to get a negative 6x to the fourth plus 9x cubed minus 10x squared plus 15x equal to 0. And the only common factor I see to everything is an x. So I'm going to factor out an x. Now, if I'm smart, or I should say, if I'm thinking about the way I like to solve this, I really, really, really don't like having a leading coefficient as a negative. So I would probably factor out a negative x. You get negative x times 6x to the third minus 9x squared plus 10x minus 15. And then we're going to factor by grouping, or we're going to try. So this thing here, I can factor out a 3x squared. I'm left with a 2x minus 3. And from here, I can factor out a 5. And I'm left with a 2x minus 3. So this factors as negative x times 3x squared times 2x minus 3 plus 5 times 2x minus 3 equal to 0. And then from, so this is, someone wrote it's 9x cubed. And I know I know I can make mistakes, but I don't think I made a mistake here because I had a 9x cubed, but then I factored out an x. So all of my x's powers became one less because I essentially divided out an x. Oh, cool. Is that right? I'm happy. Like, don't hesitate. Let me know if you think I made an error, because as you guys have seen, I've made some errors. It happens. So then to the person that asked me before about like why we did it the way we did it, this is the same kind of idea. From here, we are not, or we are factoring out the 2x minus 3 common factor. So I'm factoring out a 2x minus 3 from each of those. And what's left behind is, well, from this part here, what's left behind is the 3x squared. And from this part here, what's left behind is the plus 5. So that's why it's multiplication like that. So then we're going to set each of our factors equal to 0. We're going to have negative x equal to 0. We're going to have 2x minus 3 equal to 0. And we're going to have 3x. That shouldn't be an x squared. Oh, it should be an x squared. All right, it's totally an x squared. Yeah. And we're going to set 3x squared plus 5 equal to 0. So this one, we get x equal to 0. This one, we get 2x equal to 3. We get x equal to 3 halves. And this one, we're not going to get any solutions here. And there's two ways you can see it. You can either try solving for x like we normally do. Well, maybe not normally, like we don't normally do actually. But if you do that, you get 3x squared equal to negative 5. X squared is negative 5 thirds. But a square number can't equal a negative number. No solution. Or if you want, you could use the quadratic formula here. If you start using the quadratic formula, you're going to get x equal to negative b, the b term is 0, plus or minus the square root of b squared minus 4 times 3 times 5, all over 2. But then you can see your discriminant is negative, meaning you have square roots of negatives, which means no solution. So our solutions here are x equal to 0 and positive 3/2. Those are the solutions to this particular quadratic, or not quadratic, this polynomial equation, this higher order equation. You guys are asking good questions. Yeah, so what time is it? Okay. Time just seems to fly by in this class. Never seems like there's enough. Probably because I spend too much time talking. I will mention again, there are lots of ways to solve polynomial equations. We're not going to hit all of them. I want to say something though. So I want to point out that solving something like 2x cubed plus 3x squared minus 14x minus 15 equal to 0. Solving this is the same thing or is equivalent to finding the x-intercepts of the graph of y equal to 2x cubed plus 3x squared minus 14x minus 15. If you graph this using something like Desmos, and again, I would really, really encourage all of you to play around with Desmos. It's a very useful tool. A lot of your professors are going to refer to it. So definitely get comfortable using it, play with it, graph this, go ahead and look at what the intercepts are. But if you do graph this, you can easily find that the x-intercepts are, what do we have here? We have 2.5, comma 0, -1, 0, and -3, 0. So this means one of the ways we could try to factor this is, well, we could factor 2x cubed plus 3x squared minus 14x minus 15 as we just need x minus all of the x-intercepts. Now, some of you with keen eyes might observe that this is not right. And the way you can easily see that this is not correct, not quite correct, is if you multiply this out, would you get 2x cubed? You wouldn't. You would get 1x cubed. And so we need a 2 as a coefficient to fix that. Great, we fixed it. Now here's the thing. Of these three factors, which one wants the 2 the most? Well, clearly the one that isn't a whole number. If you actually do the 2 times the x minus 2.5, you're going to get 2x minus 5. So again, I'm really just stressing here that if you know the intercepts or you know the solutions, you can find out how to factor something. Knowing that -1, -3, and positive 5/2 or positive 2.5 were solutions to this equation, let us factor it as 2x minus 5 times x plus 1 times x plus 3. And that's an important skill. And if I had more time, so let me give you guys this problem to work on. So let's say we are given y equals x cubed minus 2x squared minus 5x plus 6. And we want to factor it. Well, let me point out. I'm going to show you that it doesn't factor by grouping, just so that you can all so that you all know when to stop trying to factor by grouping. So if I was going to factor this by grouping, I would try factoring out an x squared from the first two terms. And nothing factors out from the next two terms. That's too bad. So I guess I would factor out a -1 and be left with a 5x minus 6. Or a +1 and be left with a -5x plus 6. But either way, you should all see that no matter what I factor out from this piece here, these pieces are not the same, which means it does not factor by grouping. So what do we do? Well, this is where we would maybe use some tools like Desmos. And if we use Desmos, we can see that the x-intercepts of y equal to x cubed minus 2x squared minus 5x plus 6 are x equal to 1, 3, and -2. Or written more concisely, the points 1, 0, 3, 0, and -2, 0. So using that information, I would like all of you to try and factor x cubed minus 2x squared minus 5x plus 6. And it should factor into 3 distinct pieces. And I'm going to give you just a minute to work on that because we don't have a ton of time left. So I'll give you a minute. I'm trying to get my notes all screwed up here. All right, it's been a minute-ish, I'll pretend. So all we're doing when we factor it is if something's an intercept, then x minus that number should be a factor. So 1's an intercept, x minus 1's a factor. 3 is an intercept, x minus 3 is a factor. -2 is an intercept, x minus -2 is a factor. And then you can change that to x plus 2. So this is x minus 1 times x minus 3 times x plus 2. And if we do a quick mental check, I'm not going to actually multiply this out, but if I did multiply it out, I can see that x times x times x would give me x cubed, which is the right first term. So I'm pretty confident that this is actually how it factors, and I don't need to adjust it anyway. So that's a thing that you should do sometimes. And my papers are all over the place now. Come here, papers. So that's definitely a tool for factoring. If you know how to find the intercepts, then you can factor it. The other type of factoring we do sometimes is what's called quadratic forms with U-substitution. So for example, I want to solve x to the 4th minus 5x squared plus 4 equal to 0. And there's kind of 2 ways to go about this. One way is just to kind of see it like it's like, as I like to say, factor it normally. Yeah, so that's a good question. I don't typically ask questions where you have to use outside resources. So if I was going to ask a question like that on the test, I would say factor this polynomial given that the x-intercepts are blank, blank, and blank, for example. That's something I could ask you. So if I want to solve this, one way is to be like, well, I'm going to factor it. But I can see that I'm going to have to factor it as, well, I still want things that add to 4 and multiply it to sorry, I keep saying it backwards. That's why it's good to write it out. Multiply it to 4 and add to -5. That's going to be -4 and -1. But instead of having x here, I want x squared. Because x squared times x squared will give me x to the fourth. And negative 4x squared minus 1x squared will give me a minus 5x squared. So that's the way I would probably prefer to do it, just because it requires the least amount of writing. And then you can factor each of these further. This factors as x minus 2 times x plus 2. This factors as x minus 1 times x plus 1. And so our solutions are x equal to 2, minus 2, 1, and negative 1. But not everybody likes that. And so another way of solving it is to do what's called a U-substitution. Here is the thing you're going to do every time, no matter, so you have to recognize this for what it is. And the way you recognize it is you're going to have two different powers of x and a constant term. It's going to look like a usual kind of quadratic thing, even though it's not quadratic, right? This is a fourth power. It's not a second power, which is what a quadratic is. But the idea is that if you have a constant and two different powers of x, if one of those powers of x is twice the other power of x, then you can let u equal x to the power that's the one that's the half size power. Or as I would say, let u equal x to the power that is closer to 0. So here we're going to let u equal x squared. And then it has to be true that u squared is the other piece that we want. So whatever we choose for u squared has to also be showing up in our polynomial. And it is. So then we're going to rewrite this as x to the fourth is u squared, x squared is u, and 4 is still 4. And now it looks like a regular quadratic, and we can factor it without having to think about anything crazy. So this is going to be u minus 4 times u minus 1. Now, the thing about doing it this way is we then get our solutions. We get u equal to 4, and we get u equal to 1. But we're not done, because u was equal to x squared. So we then have to go back and go like, oh, x squared is equal to 4, which means x equals plus or minus 2. And x squared is equal to 1, which means x equals plus or minus 1.